Okay, so good day everyone. This will be the topic 3 discussion, the calculation used in analytical chemistry. So for this topic, after studying this chapter or topic, we will be able to use the SI units of measurement correctly and recognize their importance in ensuring consistency and accuracy. And then we will explain concepts of solvation, so katong mga solution, the solute and the solvent, describe concentration of the solution in a way that it's most appropriate for a particular problem or application, and we will calculate concentration of solution in molarity, normality, and the parts per solution. We will also solve problems by converting one concentration to another, and then describe the concept of dilution, and then calculate the concentration of solution prepared through simple, serial, and mixed dilution using appropriate na mga formulas. But before that, we will have first a short review. So in this slide, we will identify the types of concentration based on the formula provided. So for letter A, this is big letter M is equals moles of solute per liter. This is molarity. And then second, equivalence of solute per liters of solution, and denoted with big letter N. So it is normality. And then this one, for C and D, this is parts per solution. So for letter C, we have weight per volume. And then letter D, volume per volume. And then for letter E, we have the ppm, or parts per million. So the International System of Units, so the SI is the acronym for International System of Units, in which naka-based dito ang 7 fundamental base units. So mo ni siya ang 7 fundamental base units. So depending on the physical quantity, we have unit na fit sa iyaha. So if, for example, if we have mass, then we will use the kilogram, and then for length, we will use the meter, and then for time, second, and temperature, Kelvin, amount of substances is mole, and then electric current, ampere, and luminosity, luminous intensity is candela. So this one, the abbreviation, make sure to familiarize those na ano. So in every mga calculation, we will always use the unit na appropriate. And then numerous other useful units such as volts, hertz, coulombs, and joules are derived from these nga mga base units. So to express small, mga dagko or mga gagmay kaayo nga mga measured quantities, so we will use mga prefixes. So here we have different prefixes. So we have prefix here, and then the multiplier. So for example, if we have 1 kilo, so we can say nga that in grams is 10 to the 3. So we will use the multiplier, so para ma-determine nato kung pila siya. So for example, a wavelength of yellow light, which is 5.9 times 10 to the negative 7, or equal ra po daw siya sa 590 nanometers. So if ako ani siyang in nanometers, ako ara ning i-move into 2 decimal places para maka-add ko dira og 2. So we have the negative 9. And then for volume of liquid injected into the chromatographic column is often roughly 50 times 10 to the 6. So 10 to the 6 atong pangitaon diri, which is kani. So it is microliter. And then the amount of memory on some computer hard disk is about 20 times 10. This is positive 9 bytes. So this is 10 to the 9. So hanapon nato ang 10 to the 9 diri, which is giga. So the 20 times 10 to the 9 is equal to 20 gigabytes. So make sure to familiarize those na mga multipliers, because we will use this one for conversion of units. Okay, so we will have a example. So we will convert the following. So 5.0 gram to milligram, and then letter B, 50 kilometer per hour to meter per second. So for letter A, so we can't directly convert kilogram to milligram, so we will use the the conversion factor. So 1 kilogram is equals 1,000 gram, and then 1 gram is equals 1,000 milligram. So using this conversion factor, ma-calculate na din nato ang pag-convert from kilogram to milligram. So 5.0 kilogram times 1 kilogram. So the kilogram should be naadari sa denominator to cancel out the units. So sa taas is the gram times. So ang ato ang units to convert is milligram. So dapat milligram ang nasa taas. So we have 1,000 milligram, and then ang nasa boss is 1 gram. Cancel out the gram. So we will now have the mig. So this is 5.0 times 10 to the 6 mig, or 5 million milligram. For letter B naman, so sa letter B, duha na ang ato ang physical quantity. We have the km nga length, dayon we have the hour or second for time. So we will use again conversion factor. So 1 km is equals 1,000 meter. Okay, and then 1 hour, 1 hour is equal 60 minutes, and then 1 minute is 60 seconds. So using this information, we can now calculate the conversion. So 50.00 km over h times, since naa diri sa taas ang km, so ang naa dapat sa sa conversion factor, ang ato ang km dapat nasa ubos to cancel out. So we have now the meter. And then for second, so we have the hour here. So dapat nasa taas ang hour, 1 hour, then 60 minutes times 1 minute is equal to 60 seconds. So cancel out the km, the hour, the minutes. So ang mabili na din sa tuang unit is the meter and the second. So 50 times 1,000 times I divide 1 over 60 times 1 over 60. So the answer for this one is 13.89 meter per second. So we have 5,000 and then 13.89. Okay, so the SI units in analytical chemistry. So for analytical chemistry, the commonly used nga mga units is the mass and the volumes. The physical quantities. So for mass, so we use kilogram, grams, milligrams, and micrograms. And then for volumes naman, we use liters, ml, microliters, and nanoliters in some cases. So kani siya, mga ginagamit na to for conversion. So this will be conversion factor. So example, if nag-ask ko og pila ka cubic centimeter ang naa sa 50 liters. So 50 liters to cubic centimeter. So pag inani liters to centimeter, we will first convert liter to ml, and then from ml we use this. So ana ta nga 1 ml is equal to 1 cubic centimeter. So this is 5 to 1, 2, 3 cubic centimeter. So again, familiarize this na mga ano. So in medical laboratory, these are the common units used. So this is the laboratory references ranges in healthy adults. So again, if tanaw na to, the uses mga units para mag report og mga values. So again, these units are very important to determine, of course, the concentration of that specific na mga chemicals na present. Okay, so before to mag-calculate of molarity, let us first review the chemical solution, or we will understand the chemical solution. So a solution is a homogeneous mixture of two or more substances. So a solution may exist in any of the phase. So for example, if na ako'y NaCl salt, dahil nakuha siyang dissolve in water. So if na ako'y NaCl, dahil gi-dissolve na ko siya sa water, so I can makahimo ko og solution. So since if ma-dissolve na ang NaCl plus water, kay makahimo man ko og homogeneous nga mixture. So another example is if na ako'y sugar and then gi-dissolve na ko siya sa water, so maka-form gyapon ko og solution. Pero if ever na ako'y oil and water, since oil and water kay dili man na sila homogeneous mixture, hetero man ni sila, so pasabot wala ko'y solution nga nahimo. So a solution is consist of a solute, which is katong atong gi-dissolve, and then the solvent, which is katong nag-dissolve sa ato ang solute. And then solubility, so this is the amount of solute that can be dissolved in solvent. So for example, if na ako'y 50 ml nga water, so 5 gram of salt kay iyahang na-dissolve. Pero if na ako'y 50 ml nga water, dayon gibutangan nako siya og 50 gram pod nga salt. So if tan-aw nato ni siya sa experiment, kaning 50 gram nga salt kay dili ni siya ma-dissolve tanan sa 50 ml nga water. Pasabot naalay solute, amount of solute nga kaya lang i-dissolve in that specific na solvent. Okay, so we have here dissolution, so it means process of dissolving or forming a solution. And then solvation, ang interaction between the different nga mga solute particles sa ato ang solvent molecules. So katong interaction na ni Na plus and ni Cl minus sa ato ang H2O molecule. Okay, so if na ako'y chemical species, like for example HCl, then aqua siyang gibutang sa water. So if naay mga question nga asking kung pila ka bo chemical species ang present sa solution, then ato lang i-dissociate ang mga compounds. So for example, if we have HCl, then if na siya sa water, we have we can form two different chemical species aside sa katong water nga presentaan. Okay. So again, this will be the different na mga concentration nga dapat nato ma-learn. So we have the molarity, normality, and then the percent composition, the ppm and the ppb also. Okay, so we will now start with the molar concentration. So this is the number of solute X kay ato siyang report in terms of moles per liter of solution. So we can calculate molarity or molar concentration using this formula. So we have moles of solute divide the liters of solution. Concentration, molar concentration of solution, molarity, similar na sila og pasabot. And then the unit denotes katong capital letter M, or pwede po siya mole per liter na mga units. Okay, but we can also use this formula for easier kay later on pag calculate nato sa pila atong weight of solute, mas easier for us nga i-use ni siya nga formula. Pero if ever katong isa molarity is equals moles per liter, pwede ra pud to siya gamiton. And then same ra pud siya og answer if kani ato ang gamiton. Again, the unit for the molarity is mole per liter. So mole per liter. So laboratory preparation of molar concentration. So ginaon sa pagbuhat sa solution sa lab. So for preparation of solution sa lab, usually a solid sample ginaway na siya using the analytical balance sa beaker, and then ginadissolve siya sa beaker before nato siya isulod aning volumetric flask. And then pag nana siya sa volumetric flask, then we will add the water until there is sa iyahang mark. Pasabot if ang volumetric flask kay naay nakasulat na 500 ml, so ang ato ang pag-add sa water sa volumetric flask dapat diri rataman sa mark. So that means mao na ang iyahang 500 ml. And then we have types of molar concentrations. So we have molar analytical concentration. Molar analytical concentration, so it is a solute regardless if they undergo chemical reaction in the solution or not. And then molar equilibrium concentration, molar concentration of a chemical species. So for example, if nako in ECl nga akong gidissolve sa water, and then if gi-calculate lang nako ang molarity ni NaCl, that means gi-calculate nako ang molar analytical concentration. And then if ever naka-specify na calculate the Na plus ion or the Cl minus na concentration, that means the molar equilibrium concentration ang ginapangita. So specific na mga chemical species na present sa solution. Okay. So before we will calculate molarity, let us have first review for calculation of molar mass, mole, and of course the millimole. Okay, so for calculating molar mass, okay, to calculate the molar mass, so we will just use the chemical formula, and then we will determine each of the atomic weight dito sa atong periodic table. So for example, we will find the molar mass of formaldehyde. Ang iyahang chemical formula is CH2O. So using your periodic table, magkuha mo dito og atomic weight. So for C, for example, is 12.01. And then for hydrogen, we have 1.01. And then oxygen is 16. And then to calculate the molar mass, we will multiply the atomic mass kung pila siya kabuok nga atom present sa chemical compound. So we have isa ka C, so 12.01 plus ang hydrogen nato kay duha. So we have 2 times 1.01, and then we have oxygen nga isa, 16. So sum ato ani silang i-plus tanan, we will calculate 30.0 gram per mole. So for molar mass, we will use the the unit nga gram per mole. So next example. So calculate, find the number of moles and millimoles of benzoic acid that are contained in 2.0 gram of pure acid. So for this one, ipa-calculate sa tuwa ang moles. And then si moles kay makuha lang nato siya gamit ang ato ang molar mass, kay mao man ni siya ang we will use our molar mass. So to calculate the moles, we will start with your given, which is the 2 gram kani, and then gram times sa molar mass ta magkuha og mole. So we have 1 mole sa taas, and then 122.1 gram. Again, nasa ubos sa gram para ma-cancel out natin ning units and mabinlan ta og mole. So using this one, using your calculator, we can calculate the mole for this one as 0.0164 mole. And then to calculate the millimoles, we will use conversion factor. So we have pilagat tong conversion factor. So we have 1 mole is equals 10 to the 3, 1000 millimoles. Sorry. So we have 1 mole is equals 1000, wait lang. Again, we will use the conversion factor. So we have 1 mole is equals 1000 millimole, and then 1 millimole is equals 10 to the negative 3 moles. So using this conversion factor, we can now calculate the moles in in millimoles. So multiply conversion factor 1 mole times nasa taas ng 1000 millimole is equals, calculate. We can using your calculator. So we have 0.0164 times 1000 equals 16.4 millimoles of the acid, benzoic acid. Okay. So this one, find the molar mass of glucose. So we have glucose, again, 12 ang ato ang carbon, 12.01 times 6, unang kabuok. And then we have 1.01 times 12. Dayon we have oxygen nga 16 times 6. And then the sum ani is, again kani siya kay gikan ni siya sa periodic table, mga different atomic weight sa each of the atom. So the answer for this one is 180.0 gram per mole of C6H12O6. Next example. How many moles of monobasic sodium phosphate are present in 100 gram of substance? So again, we will, sorry. So again, we will use, we start with a given, which is 100 gram times, so kay millimoles man iyang ipakalculate niya, di man ta maka-directly og millimoles, we will use first the molar mass para naatay mole. So we have 138 gram and then we have 1 mole. So here makakalculate na ta og mole, which is 0.725 724,637. So this is mole. And then again, using your conversion factor, which is 1 mole is equals 1000 millimole, you can now calculate the millimole. So 0.724637 times 1000 is equals 725 millimole. So follow the significant figures. This is one significant figure pala. Again, kaning molar mass, dili ni siya appeal sa significant figure. Infinite ang ihang significant figure. Kani atong basihan, the given. So for this one, we have 7 times 10 to the 2 millimole. Okay. So now we will calculate the molar concentration. So since ato anang na-review ang calculation of molar mass, so we will now calculate the molar concentration. So usually sa problem, if na ay mga molar mass given, then we can use directly the molar mass. Pero if wala, then we should calculate the molar mass first para ma-use nato siya for molar concentration calculation. So we have here the example. Calculate the molar concentration of ethanol in aqueous solution that contains 2.30 gram daw of ethanol, in which ang iyahang molar mass is 46.07 gram per mole in 3.50 liters of solution. Okay, so for molar concentration, we will use katong second formula, which is the molarity is equals weight of solute, para mas uniform ato ang gamito na formula. Pero if you will use the katong isa nga mole per liter, pwede ra pud to, same ra gyapon sila og answer. So weight of solute divide molar mass times the liter of solution. So using this formula, we can now calculate the molar concentration. So molar mass is equals weight of solute nga 2.30 gram. 2.30 gram divide the molar mass. So molar mass is 46.07 gram per mole times the liters of solution nga 3.50 liters. So for liters, kani siya, the volume of solution, since liters na ni siya, then we can directly copy this one and input sa ato ang formula. Pero if naka ml ni siya, ato asa siyang i-convert to liter before nato siya ibutang sa ato ang formula. Sorry. So the molar mass, the molar concentration for this one is pila? 0. Using your calculator. 0.143 molar. Or 0.0143 mole per liter. Kani cancel out man. So we have mole per liter. Okay. So next example. This one, how many grams of sodium hydroxide are contained in 50 ml of 4.0 molar solution? So kani siya pabali ang ato ang pag-solve because gitagaan ta og molar solutions kung pila ka molar, and then gipa-determine sa tuwa if pila ka grams ang ato ang i-dissolve sa solution. Okay, so we will use the formula. Molarity is equals weight of solute divide the molar mass times the volume of solution, which is in liter. So molarity given 4.0, again molar solution, molar concentration, molarity same ra na sila pasabot. So 4.0 mole per liter is equals the weight of solute, which is mao atong i-solve. So we denote weight of solute as x divide molar mass. So since diri nga problem wala siya naghatag og molar mass, so you will calculate the molar mass of the sodium hydroxide in NaOH in A 23 plus 16 plus 1. That is 24 plus 16 0 50. Tama ba? Okay, 50 gram per mole times the liters of solution. So for liters of solution, ang given is 500 ml. So again, if ml gali ang nasa problem, ato asa siyang i-convert to liter before nato siya i-input sa ato ang formula. So kani, we have 50 ml, equivalent niya is 0.5 liters. And then cross multiply. So x is equals 40 mole per liter times 50 gram per mole times 0.5 liters. Cancel out the liters, mole cancel out, ang mabilin is gram. So we can now calculate the weight of solute as 80.0 gram NaOH. Ay, 4.0 dahil ni, sorry. 4.0 times 50 gram times 0.5 is equals 80.0 gram. So following the significant figure, we have two significant figure. So we will a final answer into two significant figure. Gram NaOH. Okay. So kani similar lang gihapon ato. So we will use the formula, this one na formula, and then since naa na tayo given na molarity, so we have molarity and then the molar mass of NaCl then the liters of solution, then we can calculate the weight of solute. Okay, so for this heat work, okay, let us try this one. So number 1, if you dissolve 0.500 mole of sodium carbonate in enough water to form 0.250 liters of solution, the molarity of Na2CO3 in the solution is, so for this one, since given naman si mole, no, wala na, dili na siya atong gram. So for those problem nga mole na siya daan, then we will use the formula molarity is equals mole per liter. I mean mole divide liter. Okay, substitute. So we have 0.500 mole divide kani 0.250 liters equals 2.00 mole per liter. And then for number 2, there are 20 grams of NaCl in 40 ml of solution. What is the molarity? So again, use the formula M is equals weight of solute divide the molar mass times the volume of solution. So weight of solute, that is 20 gram, divide molar mass for this one. So wala ta nila gitagaan og molar mass, so we will calculate the molar mass. Na is 23, dayon Cl kay 35. So we have molar mass nga 58 gram per mole. Multiply by the volume of the solution, which is 40 ml. So again, naka ml siya, so convert to liters. So 0.400 liters. And then using your calculator, the answer for this one is 0.86 mole per liter. Or if i-follow na to ang significant figure, this is one significant figure. So we will round up to 0.9 mole per liter. Okay, so for number 3, so if we have NaCl that has a molar weight of 50 gram per mole, pila daw ka grams of solute is added to 6 molar of NaCl to come up with 2 liters. So, okay, so we will use the formula molarity is equals weight of solute divide the molar mass times liter. So molarity is given nara 6. So we have 6 mole per liter is equals, again, kaning weight of solute ang ato ang isolve. So we have X divide molar mass 58 gram per mole times the the volume of the solution, which is 2 liters. So X here, cross multiply. So X here, or the weight of solute nga needed, we have 6 mole per liter times 58 gram per mole times 2 liters. Cancel out the liters, cancel out the mole, then we will have now the gram nga unit. So again, the weight of NaCl for this one is 696 gram of NaCl. So again, sa lab, dili siya directly nga calculate nato ang molarity. So usually, na ay mga tendencies nga naga-prepare ta given ang molarity, and then we calculate kung pila ang ato ang need nga solute para maka-come up ta ato nga molarity.